Question 4 asks that we determine two rates of change. The first, average rate of change from x equals 0 to x equals 2, and in part B, the instantaneous rate of change at x equals 2. So for the average rate of change, the formula on an interval, the formula is the value of the function at the right endpoint, which is f of b, because b is the right endpoint, minus the value of the function at the left endpoint, which is a in the formula. So that's f of b minus f of a. Then we divide that by the difference between the two endpoints, the right endpoint minus the left. So that is, for this function here, we have f of 2 because that's the right endpoint, and f of 2 is shown here wherever you have an x. You put a set of parentheses, and inside that x you put the 2. So this is 2 to the 4th, which is 16, divided by 2, which is 8. This is 2 cubed, which is 8, so 8 minus 8 is 0. 2 squared is 4, and so 4 divided by 2 is 2. It's negative 2 plus positive 2, so that's 0. And then, of course, evaluated at the left endpoint, this is just 0, because no term doesn't have an x in it, and so all of these are just going to be 0. So the numerator is 0 minus 0, and so we see that here. In the denominator, we subtract the left endpoint from the right, so that's 2 minus 0, which is 2, but it doesn't matter what that denominator is because we are dividing 0 by that denominator, and so that final value is 0. So the function did increase and then decrease on that interval, or decrease then increase. It did change on that interval, but it started at one point and ended up at the same point by the time that interval had passed, and so the average rate of change is 0. Now the instantaneous rate of change requires the derivative, so we take the derivative of the function, and I think we're all relatively familiar with the power rule by now, bringing the exponent around the front and subtracting 1 from that exponent. And so, of course, the exponent to the first was 4. It was 4, so that 4 comes around front here, and one of the 2's in the 4 cancels with this 2 here, right, because 4 is 2 times 2. So that leaves 2x cubed for that first term, and then the second term is 3x squared, negative 3x squared. And in this term we have a 2 here that we bring around front, which cancels with this 2 in the denominator, and so that term is negative x. And since the coefficient of the last term is the linear term is just 1, then that's 1 here. Now we evaluate the derivative at 2 to find out what its instantaneous rate of change is, and so we put we have a x here, here, and here, so we put parentheses here, here, and here, substitute the 2 in, and then of course we add the constant at the end. So 2 cubed is 8, 2 times 8 is 16, 2 squared is 4, 3 times 4 is 12, so 16 minus 12, because there's a negative here, is 4, and then 4 minus 2 is 2, plus 1 is 3. So the instantaneous rate of change of that function with respect to x at x equals 2 is 3. Now the fifth question deals with a price-demand equation, and from that we are to calculate a revenue function in order to answer a couple of questions about the marginal revenue. And we have to start with the revenue function before we can get to the marginal revenue. Well, the price-demand equation is given as a quantity as a function of price, but what we want is to isolate price so that we can then multiply quantity times price to get revenue, because that's what revenue is. And so we add 45p to both sides here and subtract x from both sides of this equation and divide both sides of the equation by 45. Not all of those steps are shown here explicitly, but I think that that's something that everybody should be able to handle. It's just a linear equation, and we're just solving for a particular variable. So this is our price in terms of x, in terms of quantity. And so, we multiply quantity times that price, and the x times the 25 is 25x, and the x times the x here is x squared. So our revenue function is 25x minus x squared over 45. That's part A of the question. Determine what the revenue function is. Then we want to determine what the marginal revenue is at a particular production level of 450 units. Marginal means derivative. So take the derivative of this revenue function, and this is a linear term, so we just use the coefficient, and we bring the 2 around front here. So this is 2x. 2 minus 1 is 1, so that's 2x to the first. So our derivative is 25 minus 2x over 45. Then we evaluate that derivative at 450. This will tell us the rate at which our revenue is either increasing or decreasing. It will be an increase if this is a positive value, as it is, and a decrease if the value is negative. So we have an x here, put a set of parentheses, substitute in the 450, and 450 divided by 45 is 10, so 2 times 10 is 20. Or you can see this as 2 times 450 is 900, and 900 divided by 45 is 20. And so 25 minus 20 is 5, positive 5. Positive 5 again means that revenue is increasing, and the rate is $5 per unit. So at a production level of 450 units, revenue is increasing at the rate of $5 per unit. Part C is the same calculation, but at a different production level, 675 units. So we calculated exactly as we did with the 450 by substituting the 675 in for the x, and 2 times 675 is 1,350. You divide that by 45 and you get 30. 25 minus 30 is negative 5. So at a production level of 675 units, revenue is decreasing at the rate of $5 per unit. Now the fact that it says decreasing here tells us that this value is negative. We would not say that revenue is decreasing at the rate of negative 5. We would not say decreasing at a negative rate. We just simply say decrease if this value is negative, and then state the value as a positive.